record it. All right, I just passed back your two-step equations maze. Anytime that you're finished with the practice this week, which sometimes I have students that are done with the practice before they even come in here, like that usually happens because they want to work on other things while they're in here. Whatever the case, you need to make sure with any free time that you have left over that you're making sure that is finished and resubmitted to get a 22 out of 22. It really should be accurate because I do provide the key. It's on the wall. Like you should look at it as you go. And you should be showing work. Like that should be really easy to show work on. So definitely finish that whenever we're not working on the practice. Today we did a super important lesson. We did a multi-step equations lesson. That has very specific steps, which you can kind of see in the learning targets, like the steps in the learning targets. In order to be successful at this, you need to be able to distribute. You need to be able to combine like terms. You need to be able to move the variable to one side. And you need to be able to isolate variables, which would be like the two-step equations. So those two-step equations are a really small part of this. All right. We're just adding in a few things before it becomes a two-step equations, but otherwise, it's just the same thing we've been doing. Some of these skills you've probably done before, like distributive property. Probably done those before. So we're going to clear up any misconceptions with some examples. If you haven't had algebra yet today and you need the practice, it's the one that says practice at the top and it also says evens or odds. If you're ever really confused though, I do link it in Schoology where you can view it and you can always just do it. But you have to show work. You have to don't just give me the answer because then it's an automatic throw. Do it on a separate paper of the work. It's not work. But let's do an example. And I'm going to call on each of you. Maybe some of you will call on multiple times. So make sure that we're paying attention and ready. Some of you love to say like, oh, I didn't do anything because I didn't know how. Well, that's what I'm spending right now doing is trying to teach you how. Again, you should have already gotten it from algebra, whoever your algebra teacher was. And now you're getting it again in here. So there's no reason. Yes. So in algebra 1, 2, like in our normal algebra class, there's not often time for a small group because the lessons sometimes take the whole hour. Like, have you noticed that? They almost take the entire time just to generally address everybody. So that's what this class is kind of for. It's already a small group and you guys were handpicked to be in here because you guys were that you have been to probably most benefit from it. So that's what this is. And like right now we're doing like a small group lesson. Am I having you all at a little table and sitting with you? No, but it's the same thing. Does that make sense? So just because I'm not sitting down with you doesn't mean that this isn't a small group. You guys are all a small group. And I'm calling on all of you individually to answer a certain part of this. All right, so the problem that's on the screen, let me get rid of everything else that's on the screen so that you can just focus on this and the steps. Also, I'll include the steps too, because some of us haven't had the lesson yet. So it would probably be helpful to have the steps. Okay, so a good study strategy would be to, these are the steps, make a mnemonic device to go with it. I don't personally have one for you, but you could make one. So like for remembering the phases of cells, like replicating, like Pedro made a taco. So like prophase, metaphase, anaphase, telophase, like that's what we mean by mnemonic device, like make something up. It goes DCMI. I don't have one for you, but I'm sure you can make one up. Um, Please excuse my dear Aunt Sally is like one that usually helps with order of operations, PEMDAS. So make one up. You need to know these by your unit test. Right now, you can reference them as much as you want. So first, you need to know for this random example I have on the screen, do I need to distribute in this? Yes. How do you know that you need to distribute? Because there's parentheses, there's a number smushed up outside of it. What does it mean when something is smushed together in math? What does it want you to do? It wants you to multiply. So I need to take this outside number, and inside the parentheses should be like either addition or subtraction. That's how you know to distribute it. Looks like what's here in the red. Now, Lila, what do I get when I multiply 8 times y? Okay. Nope, you're multiplying. So distributing is multiplying, right? Because it's a number smushed up against the parentheses. So we're multiplying it by the first term, which is y. So the question is, what's 8 times y? Let's see. So that's just one piece so far. There's still another piece, but I just want to know from you, what's 8 times y? So whenever it's a number times a variable, how do I write it? Because can I know what it equals actually? I don't know what y is. That's what we're trying to figure out.
Yeah.
So how would I write it? Not equals y. Yes, because when it's a number smushed up against a variable, that implies what class? Multiplication. So if I'm asking you what's 8 times y, 8y is what I want you to write. Elena, what's 8 times 4? Good, and you guys can use a calculator for that part at least. Like the calculator can do the multiplying, the adding, whatever, but it cannot do things with letters. So that's why you have to know some things by yourself, but the calculator can do a lot of other things. So that's me distributing the 8. I also have to distribute here. This is a -2. So a common mistake is some students will just multiply this by 2. You always keep the sign that's in front of each term and consider it when you're multiplying, adding, whatever the case. So this I'll be multiplying a -2 by these. So Lila, what's -2 times y? 2. Okay, good. Kaylee, what's -2 times -1? -2 times -1. Good, a +2, so I'm gonna write +2 here. And that is me distributing. So that's me distributing in the blue, this is what I get, this is me distributing in the red, this part. And the signs are determined by what they are after multiplying. So like this was negative, so that's why I put -2y. This became positive, the negative times the negative is a positive. And then I'm gonna write down what the other stuff was that we haven't touched yet, that just gets brought down. So far I distributed. Questions on that? Okay, next you need to combine like terms. So that means look on like this side of the equal sign only. Do I have any like terms on this side? Good, I have, and what like terms means is it has the same variable to the same exponent, but we're not really good with exponents right now. So same variable, the 8y and -2y are like terms, and you keep the sign that's in front of each term. So when I'm adding, combine means add, Ariana, what's 8 plus -2? Good, and that's gonna make it a 6y, because when we combine like terms, the variables stay the same. Number in front changes, 8 plus -2. And then I do have other like terms. Ion, what's my other like terms on that left side of the problem? No, this side. So we already combined the y's. What else can I combine? Good. So I can always combine the constants, the single numbers that don't have variables at all. And you can add those in your calculator if you need to. Class, so it's 32 plus 2, 34. And that's going to be plus 34 then, if it's positive. Bringing down the other stuff. Gracie, on the left side, are there any like terms to combine? Yeah. Gracie. No, because one has a y and the other one doesn't. So no like terms there. We're on to our next step, which is move the variable to one side. Say, do I need to move the variable to one side, or is it on one side already? I do need to move it to one side. Doesn't matter which one you move. It doesn't matter. It is usually easier though to move the smaller one because then you'll work with fewer negatives, but it doesn't really matter. So it'd be easier if we move the -3y though. Olivia, how would I move the -3y? Good. So we do it here to cancel it out, whatever you do on one side. And notice I'm lining it up with its like term. You just need to add it once on each side. You don't need to do it to each term. There's once on each side of the equal sign. Here so that it cancels out. On the left side to keep it equal. That's plural. Whatever you do to one side will be to the other. Pearson, 6y plus 3y is 9y. Bringing down everything else. So plus 34 equals 70. Now this is the same as what we've been doing. The two-step equation, the isolating the variable. Looking at everything that's being done to it and getting rid of what is farther from it is how you do that. Yes? Okay. We decided to do that. We decided to do that because we have to move the variable to one side. And the only way you can do that is by canceling it out on one side. So you ask yourself, how can I make this go away? Well, if it was 70 plus a 0, I wouldn't have to write it anymore, right? So how can I make -3y 0? 3. You add 3y, and yes, you do it to the other side to keep it equal. So that's the rule. Good question. Any other questions right now? Okay. So now you look at everything that's being done to it. Shiloh, what do I need to get rid of first? The 9 or the 34? How do I cancel it out? Good, whatever I do on one side. So then that cancels. I get 9y equals. This you can do in your calculator, but I think it's 36. Feel free to check me on that. Okay, good. And then Nathan, what's the last step to get the y fully by itself? Divide, because that would be the opposite of multiplying, because they're smushed together, so we're doing the opposite. Whatever you do on one side. Good. So we're dividing 9. That gets the y fully by itself. 36 divided by 9 is a +4. All right, so that's, and we covered everyone. I asked everyone at least one part of it. But if you need more examples, let me know. And then remember, here's how you can check your answers too, aside from just looking at the key over there, because I do have the key to this practice on the wall too. But remember, solutions are values for the variable that make it true. So I should be able to plug in 4 for the y in the original problem. And it should give me something that's true. So that's what I'm doing right now. I'm typing it exactly as it was, but just where there was a y, I'm putting parentheses and a 4. And then on the other side, it was 70 minus 3y, so making it a 4 now instead of a y. Look, they equal the same thing. So that's how you can check your answers. It should make it true. I'll leave this up on the screen so you have an example, but also I want to remind you, this was another part of the notes. If you ever run into a situation where it cancels out completely, so like you're moving things to one side and it cancels out completely, you either have a no solution or an infinitely many solutions. How you know depends on what remains. So like if what remains makes no sense, like -4 does not equal -2, then it's no solution. If it gives you something that is true, then it's infinitely many solutions, but that's only if you're solving and you see that it cancels out completely the variable. That doesn't happen often, but when it does, refer to this part of your notes. All right, any questions right now? Do you think that's good to get you started? I'll slide this down a little bit. Again, let me know if you have questions as you go. It's all on paper today. And then any extra time, work on your maze.